This is a video about parallel resistance and current dividers. What is parallel resistance? Well, it's the equivalent resistance when you have two or more resistors or resistances in parallel. And a current divider is how the current divides between those parallel resistive elements in a circuit. So if you have a circuit here with two resistors in parallel, the current is going to split between those two resistors in a manner that is dictated by the value of these resistors. Here's some formulae here that related to this. The parallel resistance of the equivalent resistance of resistors in parallel is going to be, the reciprocal of that is going to be 1 over R1 plus 1 over R2 plus 1 over R however many other resistors you have in the circuit. So in order to find the equivalent resistance of this, you would just plug it into that formula and that would yield your equivalent resistance. The total resistance in such a circuit is going to be your source voltage divided by your parallel or equivalent resistance. The total current is also the current going through each element of the circuit. So if you have two resistors in the circuit, it's going to be the current passing through that resistor plus that resistor is going to equal the total current. If you have three resistors, then it's going to be split into three separate branches, and the total is going to be these three branches added together. Now if you wanted to find, say, the current through one of these resistors, you would just take the total current as defined by your voltage source divided by your parallel resistance. Then you would multiply it by the parallel resistance divided by that resistor. So if you wanted to find the current through R1, you would take the parallel resistance divided by R1 and then multiply it times the total current, and that'll give you the current through R1. And that holds true for however many resistors you have in a parallel circuit. And finally, we have Ohm's law. Basic formulas here. There are some rules associated with parallel configurations, and that is that the voltage across all of these resistors, all of these branches, each one of these elements are all going to be the same. So R1, R2, and R3 in this example are all going to be 9 volts across each other. So that's a very simple rule. And the other rule already touched on is that all these currents here, however many branches you have, add up to the total. So we've got a breadboard here, and we've got 3 different scenarios. We're going to go ahead and calculate a few things. First, we'll take this circuit right here, and we're going to go ahead and calculate that parallel resistance. It's very simple. If you just plug it into the formula, 1 over Rp is 1 over R1 plus 1 over R2. You got two 1,000 ohm resistors. 1 over 1,000 plus 1 over 1,000 is 2 over 1,000. Then you have 1 over 500. The reciprocal of that is 500 ohms. So in this circuit, the parallel resistance is 500 ohms. Now, if you wanted to find the total current through this, it's simply going to be the voltage divided by the equivalent resistance per Ohm's law. So in this case, you would have V source, which is 9 volts, divided by your parallel resistance, which is 500 ohms. 9 divided by 500 is going to give you a total current of 0.018 amps. Now, what about the voltage across R1 here? Well, that's the simplest of the rules, is that the voltage across each of these parallel elements are all going to be the same. It's going to be equal to the source voltage. So the voltage across R1 here is going to be 9 volts because that's the source voltage. Now, what about the current through R1? Well, so you just take the parallel resistance, the equivalent, 500, divided by R1, which is 1,000. So you have 500 divided by 1,000, which gives you 1/2 times 0.018 or 0.009 amps. So this will have 0.009 amps going through R1. Now I've got actually an amp meter here. So I'm going to go ahead and measure that current going through R1. Let's see how we did. In order to do that, I'm going to break into this R1 here. Both of these resistors are in the this configuration in this circuit right here. We have two 1K resistors, and we're going to open up our 1, and we're going to insert the amp meter leads between the top of the resistor and right there. We're basically breaking into the circuit. We're breaking into this I1 right here. We're going to measure that. And that gives us 9 milliamps, which is 0.009 amps. What about this circuit right here? This one you've got 3 1K resistors, or 1,000 ohm resistors, all in parallel. What would be the parallel resistance, the equivalent resistance of these 3 resistors in parallel? Well, according to the formula, you would have 1 over 1,000 plus 1 over 1,000 plus 1 over 1,000, which would be 3 over 1,000. You take the reciprocal of that, it gives you 1,000 over 3, which comes out to 333 ohms. So that's the resistance that this 9 volts is actually seeing over here. That's the equivalent resistance. So in order to find the current, you're just going to go ahead and do it like we did before. It's going to take your source voltage, you divide that by your parallel resistance. That's 9 volts divided by 333 ohms, and you've got 0.027 amps. Now that 0.027 amps is going to be used to calculate, for in this case, we're going to go ahead and find the current going through R2. Just this one branch right here. Now you can probably guess if you've got a total current of 0.027 amps, and all these resistors, by now you can probably guess, all these resistors are the same value, that I1, I2, and I3 are all going to be distributed equally. So if you have 0.027 amps, you divide that 3 ways, each of those is going to be 0.009 amps. So we should end up with 0.009 amps. So if you have RP, which is your parallel resistance, you divide that by R2, which is 1,000, 333 divided by 1,000, times, which is 1/3, and that's what we thought here, 1/3, times 9 volts is going to give you 0.009 amps. Now, if you remember, that was also the answer up here, 0.009 amps. Now you notice that they're the same. Well, that makes sense because actually there's another way to calculate this. You have 9 volts divided by a 1,000 ohm resistor. So no matter how many of these resistors you have in here, each one of them is going to have 0.009 amps going through it because of Ohm's law, 9 volts divided by that. You're just increasing the amount of current. So the more resistors you put in here, the higher the total current is going to be. So let's do one last circuit right here. This is going to have 2 resistors in parallel, but each one of these is going to be, so these aren't going to be the same value. One's going to be different. So you got 1,000 over here, you got a 500 ohm resistor over here. Let's go ahead and calculate the parallel resistance there. And parallel resistance here is going to be 1 divided by R1, 1 divided by R2. This is maybe 1 divided by 1,000, 1 divided by 500, and 1 divided by 500 is 2 divided by 1,000, actually. So that's that. So we end up with 3 divided by 1,000. That's 3 divided by 1,000. The reciprocal of that is 1,000 divided by 3, or 333 ohms. Interestingly, the parallel resistance of this circuit is the same as it was in the previous circuit because it just actually turned out that way. Now, to find your total current is going to be your voltage source divided by your parallel resistance, 9 volts divided by 333 ohms, which is what we found here, and we're going to end up with 0.027 amps, which is what we had before on the other one, 0.027 amps. All right, so now IR2. So this is a 500 ohm resistor, and if you notice, these are out of balance now. So this is not going to split evenly. If you want to guess which one has more current, then look at the resistance. The one that has more resistance is going to resist more current than this resistor here. So it would make sense that this resistor is going to have the most current because it's resisting the current flow less than this resistor right here. So IR2 is going to be RP, which is your parallel resistance, which we found to be 333 ohms. You divide that by R2, which is 500, and then you multiply that times 0.027, which is our total current, which we came up with. And that gives you 0.018 amps. Now that means that you have 0.018 amps going through this one here, and the remainder is going through of the 0.002 amp 27, or rather the 0.027 amps. The remainder is going through here, and that would be 0.009. So you see more current, as we expected, is going through R2 because it's of lower resistance, and it's a proportionally lower current, or a higher current is going through R2 is what we expected, and it's a proportionally higher current based on the proportion of the resistance values of the parallel total equivalents. So that gives us, go ahead and confirm this in a couple of ways, and one of them would be, how would we confirm that we have 0.018 amps going through here? Well, you got 9 volts. You divide that by 500, and 9 divided by 500 is 0.018. Another way you can do it is actually measure it, and this is what we have right here. We've got a breadboard. You got 1,000 ohms here, and you got 500 ohms here. And I'm going to break into this circuit here. I'm going to break in right here. Basically just cut in right there and connect an amp meter right there to measure the current. There's a meter right here. Let's go ahead and measure that. I hope you can see that. So we should get 0.018 amps. 0.018 amps going through there. And let's go ahead and measure the other one while we're at it. We should get about 0.009 amps. And that's what we get, 0.009 amps, right on the money. So that's a little video on parallel resistance and current dividers, and I hope you found that helpful and informative. So here's a problem for you. Consider this circuit right here. We have a 10 volt source and 3 resistors in parallel, 1,000 ohms, 500 ohms, and 1,000 ohms. What is the equivalent resistance of this circuit that the voltage source sees here? Well, so you're going to need to use the parallel resistance equation, which is 1 divided by Rp, which is R parallel, is equal to 1 over R1 plus 1 over R2 plus 1 over R3, which is equal to 1 over 1,000 plus 1 over 500 plus 1 over 1,000. Now 1 over 500 is actually equal to 2 over 1,000, so we can change that to 2 over 1,000 there. Let's just do that just to make it easier. So that's actually 2 over 1,000, which gives us 4 over 1,000. The reciprocal of that, Rp is a reciprocal of that, which is 1,000 divided by 4, or 250 ohms. So this resistance of the circuit is 250 ohms. What is the circuit current? Simply going to be Ohm's law, I is equal to voltage divided by resistance, 10 volts divided by the circuit current, which we just found to be 250. So I is equal to 10 divided by 250 ohms, or 0.04 amps. That's also 40 milliamps, or 41 thousandths of an amp. So that's 0.04 amps. That's your circuit current right there. What is the voltage across R2? Well, the voltage across R2 is simply the voltage across R2. Whenever you have a parallel circuit like this, whatever the voltage source is whatever the voltage is across each element. Each one of these has 10 volts across it. So that's the answer to that. 10 volts. What is the current through R2? Okay, so there's another equation for that. The current through a resistor in a parallel circuit, R2, is going to be equal to the total current, I total, which we found to be 0.04 amps, times RP, which is a parallel resistance, equivalent resistance, which we found to be 250. It's going to be whatever the circuit resistance is, divided by the resistance of that resistor. So R2, we're trying to find the current through R2. So whatever that resistance is. So this is equal to I total, is 0.404 amps, times parallel resistance, equivalent resistance, 250 ohms, divided by R2, which is 500 ohms. So you basically, what you have here is you've got 0.04 amps times 250 divided by 500, or 0.04 amps times 1/2. That's going to be equal to 0.02 amps. And that's going to be the current through R2, 0.02 amps. Now, what is another way to find this current through R2 without going through this equation here? Well, just using Ohm's law, you know the voltage. We already found out what the voltage is across R2. That's 10 volts. You know the voltage and you know the resistance, you can find the current. No problem. It's your voltage divided by your resistance. So the current through R2 is 10 volts divided by 500, which is also equal to 0.02 amps.
I hope you found this video interesting and informative. If you did, please like this video and subscribe to this channel. For more detailed information on this project, as well as recommended breadboarding equipment, best practices, and safety tips, please go to breadboardcircuits.com. Thank you.